Okay, so in this next problem we're told that the cost of sending an overnight package from Los Angeles to Miami is $23.40 for a package weighing up to but not including 1 pound and $3.75 for each additional pound or portion of a pound. A model for the total cost C in dollars of sending the package is C equals 23.4 plus 3.75 times the least greatest integer function of x, where x must be greater than 0 and x is the weight in pounds. And we're asked to sketch a graph of the model and then determine the cost of sending a package that weighs 9.25 pounds. So let's start by tackling part A. So we have this function here. We know it's C equals 23.4 plus 3.75 times the least greatest integer of x, our step function. So what I'm just going to do is I'm just going to plug in numbers for x and see what happens. So first I'm going to plug in integers. I'm going to plug in 0 for x because that's the simplest number that I can think of. So if we plug in 0 for x, we would get 23.4 plus 3.75 times the least greatest integer value 0, which would be 0, which would then change to 23.4 plus 3.75 times, let me do that again, times 0. And remember, 0 is the least greatest integer value 0 because 0 is the integer. So, and this is a times symbol anymore, or this is a times symbol now, because now that we've evaluated what the least greatest integer would be, we can write it in parentheses and multiply it by 3.75. So 3.75 times 0 would be 0, and 0 plus 23.4 would be 23.4, giving us the ordered pair 0, comma 23.4. So if we say, for example, this is 20 and this is 25, and we go up by 5s on the y-axis, but we go over by 1 on the x-axis. 0 would be right here, of course, and 23.4 would be somewhere right here-ish. And now, if you think about it, any number between the 0 and 1, the least greatest integer would go back to 0. So for example, if we plugged in 1/2 for x, the least greatest integer value of 1/2 is 0, because you're looking for the least greatest, which would be, it can't be 1 because 1 is greater than 0, so it would be 0. And so basically all the way up until the point 1, the least greatest integer value would go back to that 0. And then as soon as we hit 1, we get a new point, basically. So if we do it for 1, then we get 23.4 plus 3.75 times 1. Again, it's times because we evaluate the least greatest integer at 1, and we evaluate it to be 1. The least greatest integer value of 1 is 1, if that makes any sense. So then we'd have 23.4, and 3.75 plus 1 is just 3.75. So that would be just 3.75 like that. And then our answer would be 27.15. So our new ordered pair, or our second ordered pair, would be 1, comma 27.5. So we go to 1 and we go up to 27.15, which is going to be around there, and we make a new closed circle, and then here we make an open circle because we're saying up to but not including 1 pound. That would be the cost. And so you would basically do that for any other x coordinate for x equals 2, x equals 3, x equals 4, so on and so forth. And you would get a graph that looks something like this. It would just be a normal step function. Let me draw this out a little bit so that it goes to 2 like that. And then it would be an open circle. And then somewhere above it, it would be another closed circle going to the next integer, which would be 3, and so on and so forth. So your graph would look something like this, just like a step function. So then for part B, we want to determine the cost of sending a package that weighs 9.25 pounds. So what we're going to do is plug in 9.25 for x and see what our cost is, our C value. So we go 23.4. Let me write it up higher actually. 23.4 plus 3.75 times the least greatest integer, the least greatest value integer of 9.25, or evaluated at 9.25. And so what we're going to do is we're going to treat these double brackets here as if they were parentheses, in that we're going to evaluate what the least greatest value integer of 9.25 is. And what we'll find is that the least greatest integer of 9.25 is 9, because you're looking for the least greatest integer. So your choices are, the closest integers to 9.25 are 9 and 10, and 9 is less than 10, so that would be your least greatest value integer. So we do 23.4 plus 3.75 times 9, and if you were to multiply 3.75 times 9 and add it to 23.4, you'd get that your answer is 57.15, and the units that we're working with here is dollars. So $57.15 to send a package that's 9.25 pounds, and that's how you would do that one. Okay, so in this next problem we're told that a mechanic is paid $14 per hour for regular time and time and a half for overtime, and that the weekly wage function is given by the following piecewise defined function, which is W of H equals 14 times H when H is greater than 0 or less than or equal to 40. And it's also defined by 21 times H minus 40 plus 560 when H is greater than 40. And H is the number of hours worked in a week. And in part A, they ask us to evaluate W of 30, meaning the mechanic worked 30 hours per week, W of 40, W of 45, and W of 50. And then in part B, they say the company increased the regular work week to 45 hours, and they're asking us to what the new weekly wage function is. So let's go ahead and take care of part A first. So right here, I've got all of the points that they want us to evaluate the function at, and first they want us to evaluate W of 30. So we look here, 30 is greater than 0 and it's less than 40, so we're going to be using this piece of the piecewise defined function. So that's going to give me 14 times 30, which if you multiply that out, you'll get 420, meaning that the mechanic would earn $420 that week. So if we go to W of 40, we look here, 40 is greater than 0 and 40 is less than or equal to 40. So we're still going to be using this top piece right here. So that's going to be 14 times 40. And then if you go ahead and multiply that out, our answer is going to be 560, meaning that the mechanic would make $560 that week. Now, W of 45, if we go over to the piecewise defined function, we see that 45 is greater than 40, so we're going to be using this equation right here. So that's going to give us 21 times 45 minus 40 plus 560. So we go ahead and subtract 45 minus 40, and we get 21 times 5 plus 560. Sorry, that's a little bit messy. 21 times 5 is 105. So we are left with 105 plus 560, which is going to give us 665, meaning that the mechanic would make $665 that week. Then at W of 50, once again, 50 is greater than 40, so we're going to use this bottom equation right here. So that's going to be 21 times 50 minus 40 plus 560. Then 50 minus 40 is 10, so it's 21 times 10 plus 560. And 21 times 10 is 210, so we are left with 210 plus 560, which is 770, meaning that the mechanic would make $770 that week. So those would be your answers for Part A. And then we can move on to Part B, which says the company increased the regular work week to 45 hours. What is the new weekly wage function? So the new weekly wage function would be W of H equals, and it would still be piecewise defined, and it would be 14 times H when H is greater than 0 and less than or equal to 45. And then for the bottom piece, it would still be 21, because that's time and a half, times H minus 45, because now the new overtime minimum is 45 hours,